So today we're going to use arithmetic properties to simplify expressions. That's our topic today. And you will find that these properties, you already know how to do them. You just don't know what they're called. For example, do you all know that if I have two numbers, like I'm going to use two variables. If I have a plus b, what is that same as? Yeah, b plus a is same as b plus a, right? You all know this, right? 2 plus 3 is same as 3 plus 2. And do you guys know, so you all know that's true, right? But do you guys know what we call this property? Yeah, you know this one? Say it again? Okay, yeah, close. Commutative property of, what operations do you see, guys? Addition, very good. It's called the commutative property of addition. So really, we know this. This is a fact that we already know. If you add two numbers, doesn't matter which order you add them, you get the same answer. Okay, so today we're going to learn these names, right? And because today's homework is going to ask you, right? They're going to give you an example like this and they go, okay, what property are they using, right? And you have to be able to identify, okay? Huh? Okay, good. Now, do you guys know there's another operation that we could use that doesn't actually, there's another operation that it doesn't matter which order you do it in. Would it work for subtraction? No, of course not, right? So we don't have commutative property of subtraction, but we do have this for, yeah, what do you think? Multiplication is correct. So for example, let me just do it with some variable. A times B is same as B times A, right? You all know this, right? 3 times 4 is same as 4 times 3. Anybody want to guess what the name of this property is? Hint, hint, look at what we have here, all right? Yes, sir? Commutative property of multiplication. That's correct. So this one is called the commutative property of multiplication. Okay, very good. So I'm going to write this in words here for you. It just means that the order in which you add or multiply two numbers. Actually, it doesn't have to be just two. It could be if we're all adding like 3 numbers or 10 numbers all together, or multiplying 3 numbers or 10. But let's start with 2. In order which you add or multiply 2 numbers does not affect the result, okay? So the change in order does not affect the result, does it? Right? When you change the order, it doesn't change the result. Okay, I'll give you time for you to write. Okay. I'll wait. Okay, another fact you guys already know. If I have, like, for example, 3 numbers, let me just use variables, A plus B plus C. Okay, you would, add these first two numbers first, right? Now, do you always have to add it this way, or can you do it in a little bit different way? Yes, sir?
You use C plus B plus A, right?
Yeah, you don't have to add, oops. You don't have to add the first 2 numbers together. You could add the last 2 numbers. Can't you not? Yeah. Right? Imagine if you have like number 1, 2, 3, like 1 plus 2 plus 3. It doesn't matter if you add 1 plus 2 first or like 2 plus 3 first, right? So there's a name for this property. Also, does it work for any other sort of operation? Yeah. Yeah, it will again work for multiplication. Would it work for subtraction? No, it won't. Okay, you're gonna get it wrong. So yes, it also works for multiplication. And notice you are grouping them differently. You know what I mean? By the way, do we change the order at all? No. You got A, B, C, A, B, C, A, B, C, A, B, C, right? We don't change the order. But of course, when you're actually doing the problem, right, you don't do it in the same order. You do the first one and then the other one, you do the last 2. So anybody know what we call this property? A lot of you? Okay, some of you. How about Lisa? What do you think? No, I'm sorry. How about Libby? What do you think? Transitive? No, actually we are going to learn transitive property today, but this one is not called the transitive property. Aiden, do you remember what this? I'm going to give you a hint. It starts with A, like your first name. Shh. You can't remember? Okay, that's fine. That's fine. Let's see if someone else who could help Aiden here. How about Sammy? What do you think? Yes, the associative property of course, the first one is the of. What? Addition. The other is associative property of Multiplication is correct. So I have it right here. And notice that we do not change any order, right? It was A plus B plus C. Again, A plus B plus C. It's just, you know how you associate things? You know, see how we're associating them differently? That's all. That's why it's called associative property. And in words, grouping or associating numbers does not affect the result when adding or multiplying. That's what it's doing, right? And I even give you some examples down here with numbers 2, 3, and 4. Okay? And please note that this has no change in order. Okay? It doesn't. You don't change anything, right? The order doesn't change. So go ahead and write it down. I'll wait. I want you to notice something here. I don't know if anybody noticed. Do you see why for commutative property I highlighted the C right here and change in order? What do you think I did that? Oh, it's frozen. Here. You know, I highlighted the C for change in order. What do you think I did that? Anybody? Chris, what do you think I did this? Yeah, the commutative property starts with C. Okay, so remember C for change in order. Does that make sense? Look at the associative, because this one, do we change anything in order? Do we change the order at all? The associative property? No. So sometimes people get confused with these two, right? For associative property, people write commutative property, which is wrong. Okay, so if you do not see any change in order, guess what? It's going to be an associative property, right? If you see a change in order, guess what? That's the commutative property. C for change. Okay, please keep that in mind. Are we good? All right, let's move on to the next part. So we're gonna switch gear a little bit. If I have A plus B, I'm gonna give you some vocabulary words here. Does anybody know what we call A and B? These two variables. When it's separated by an addition sign, it starts with T. A and B are called one person? Yes, sir.
Tangents.
Tangents. Wow. No, actually, that you learned that in geometry or trigonometry. Yeah, that's a ratio of. Anyway. No, that's something. It starts with T. A and B are called, because people always get mixed up. It starts with T. Anybody know? Is called. Okay, let me just tell you. A and B are called TE. Yeah. What do you think, sir? It's T. Terms is correct. Terms. Okay, these are called terms. The reason I'm giving you this is because people get confused with this. What if you have multiplication in the middle? Do we call A, B terms also? No. Okay, they have different names for these. Okay, so if you have addition in the middle, so terms are separated by addition. These are called terms. If you have multiplication, they're not called term because people keep on calling them terms also. Anybody know what they're called? It starts with F. Yeah. Factors. Very good. These are called factors. Okay, so please keep that in mind. And this is kind of, I see this a lot. People refer to these, with using the wrong, names. Okay, so if you have addition in the middle, these are called terms. If you have multiplication, then these are called factors. Okay, so please keep that in mind. All right. So some of you may be wondering. So then, how are they going to ask, right? How to identify these properties on your homework and so forth. So this is what they're going to do on your homework today. It's going to say, example 1, name the property that justifies each step. In other words, which property are they using, okay, that allows them to write this next step. So what they're going to do first is they're going to give you this simple sort of question. You all know how to do this, right? But they're not asking you to just simplify. They're going to say, first of all, it's given to you. Because, why do you call it given? Why do you think it's called given? It's because they give it to you. It's give. Okay, so then next step, they're saying this. They give you this next step and go fill in the blank on the right, which means they want you to justify. How is it that they're able to write the second step from the first step here? Does anybody see any difference between first step and the second step? What do you see? Yeah. Yeah, there's a grouping symbol between 21 and 3, right? So how is it that they're able to write that? By the way, is that okay to do? Yeah, it's okay. Now, what tells you that that's okay? What property tells you that, oh, that's legal, right? The math, right? Dana, what property tells you that? It's exactly right. So you're going to write associative property, of course, of addition, because all the operations are addition there. So that's the kind of question they're going to ask you. They're going to put a blank space there, and they're going to go, okay, what property allows you to write that. Okay, how do you go from first step to the second step? Do you see the kind of question they could ask? Well, they're not going to stop there. They're going to go more. Of course, they could simplify this more. They're going to go this way. Does anybody see anything that's changed? What changed from second step to third step? Eric? Eric? Yeah. Look, man, from second to third step. What?
Solve?
No, like what changed from second step to third step?
21 plus 3.
Yeah, 21 plus 3 became 24. Now, what property are they using? Now, this is a property that we haven't learned today. We actually learned this in the, I think, first day or something. No, not first, second day. Because first day we didn't do anything. Second day, we learned on the second day. Anybody know what property they're using? Instead of writing 21 plus 3, they wrote 24. They are replacing that expression with another expression that has the same value, aren't they? Isn't 21 plus 3 same as 24?
Yeah.
What is this property called? Jason, what do you think?
I'm gonna guess it's substitution.
You are correct. You guessed it right. It is called the substitution property. Right, guys? You see, remember we talked about substitution property? What that is simply replacing an expression with another expression that has the same value. Would you not agree that 21 plus 3 has the same value as 24? Yeah? Are we okay? Does this make sense? Okay, now they're going to write this. Eric, let me ask you this again.
Yeah.
Instead of 24 plus 10, they wrote 34. What property do you think they're using here? By the way, don't say addition, because that's not a property. That's just an operation. Okay. What property do you think they're using?
Solving property?
Huh? There's no solving property. Look at the previous. Eric, we wrote 21 plus 3 as 24, right?
Substitution property.
You got it. It's the same property as above. They're using substitution property again. In place of 24 plus 10, they're using 34. Don't they both have same value? Okay. Right. So this is the kind of things you have to do for your homework tonight. Does that make sense? This is how they're going to see whether or not you understand these properties. Okay? Some more example. Here's another example that's similar to what we had. Again, they're going to give it to you. It's given. Okay, the first step is given. They give you this problem and they go, okay, how do I go from here to here? What property are they using here? How about, so write this down. I want you to all think about this. I'll call on somebody at random. All right, write this down. 50 times 9 times 2 times 9. Now, instead of that, they have a parentheses, grouping symbol in the middle, around 9 and 2. Samuel, what property do you think they're using here? Hmm? Associative property of what? Operation. Multiplication. How many people agree? Samuel says it's the associative property of multiplication that allows us to write, and this is correct. You guys are right. Okay, it's the associative property of multiplication. Okay, do you see the kind of game they're playing here? Next, they give you this. I would like you to all to think about this. How did they go from second step to third step? What property? Go ahead, write it down. I know that a lot of you already know this. Go ahead and write it down. I'll give you time. Okay, I'll give you time. They now have, instead of 9 times 2, they have 2 times 9. And I will, after you write, I'm going to call on somebody at random. How about Angels? What do you think? What property do you think they're using here? Instead of writing 9 times 2, they now have 2 times 9. Let me give you a hint. Did they change this did the order change? Okay, so guess what property they're using? You're exactly right. It's the commutative property of what operation? That's correct. On the test, do you think it's okay to leave out? Can you just write commutative property? No, you gotta tell me which operation, okay, that we're using here. Does that make sense? Yes? Okay. All right, let's move on to this. What property are they using here? I want you to all think about this. I will call somebody at random in a minute. Go ahead. So notice what changed from the step above. They had 50 times in parentheses 2 times 9 and then times 9. Now they have 50 times 2 in parentheses and then times 9 times 9 in parentheses. So what property is this? What is it that they're using here? Who haven't I called today? I haven't called. Christina, what do you think? Commutative. So you say commutative. Remember C for change. Do you see any change in order from third? No. So be careful. That's why a lot of. So what? It's the associative property of multiplication, because look, they group these two. Remember, associative means kind of grouping. Same thing as grouping, right? They group 2 and 9. Now they group the other two. Does that make sense, Christina? So now this is not commutative, but this is the associative property of multiplication. Are we good there, guys? All right. Now let's move down. Now they have this 100 times 81. Okay. Okay, hold on. Okay. So Chuck thinks he knows. Okay, just everybody write it down. I'll wait. Okay, so I'm gonna call somebody at random. Okay, so just write it down. Song, what do you think? What did you get? So how many people agree with Song? Substitution? A lot of you. Anybody have a different answer for this? Okay, Song is correct. It is. They're using substitution. By the way, for substitution, there's no substitution property of addition, or there's nothing like that. It's just substitution. Okay, so don't write anything like that. Okay, now of course they're gonna write 81, 100. Of course, what property is this? Here. Okay, I'll give you time. Go ahead, write it down, and then I'll call on somebody at random. Carolyn, what do you think?
Substitution.
How many people agree with Carolyn? This is substitution. You are correct. It is a substitution. Okay? Any question as to how to do this so far? And do you see something nice about this? Okay, normally if you see 50 times 9 times 2 times 9, what would you multiply first, normally, guys? Yeah. 50 times 9. But do you see, using these properties, right? Look how nicer it became, right? If you were to multiply 5 times 2 and 9 times 9, isn't that a lot easier to get the answer? Does that make sense? So using these properties, you can simplify these expressions in a simpler way. Okay? Does that make sense? Here we go. Properties of equality. So these are going to be some kind of properties of equality. That's why we gather them as properties of equality. So the other ones that we learned, the previous 4 properties, they weren't properties of equalities, right? They were just commutative property of addition, subtract, what else? Associative property of addition or multiplication, and so forth. Now you're going to have some kind of property of equality. So I'm going to tell you the first one here. This one's kind of interesting. Just if you have a same number equal to itself, okay? There's a name for this property. Anybody know what this is called? Think about a mirror. When you reflect yourself in the mirror, you get yourself back, right? Yes, sir? Almost. It's not reflective property. It's called reflexive. So because I always talk about the mirror, people actually write down reflexive. Okay, it's not reflexive. It's reflexive. F-L-E, okay? So please remember. So again, it's called reflexive property of then equality. Remember I told you these are going to be whatever property of equality. So this one is called reflexive property of equality, okay? So you have to know that one. Next property of equality I want to tell you is this. If A is equal to B, then what about B equals, what does B equal to? Anybody have any guess? Chuck?
A.
Yeah, you're right. So if A is equal to B, then B equals to A, okay? This has a name, question? Oh, you think you know what it is? Hold on. Okay. Okay, actually, yeah, what do you think it is? Not quite. No, it's not called transitive. It's coming up, you're right, but this one is not transitive. By the way, doesn't this look like sort of like a commutative property? You see the change in order? But if you look at carefully, this is not going to be commutative property. We have 2 commutative properties, right? Commutative property of addition and commutative property of. Do you see any addition and multiplication on this?
No.
No. And how is this different? Even if you see it, yeah, Claire?
Commutative, it's adding or multiplying, and this is equal to.
Yeah, this is equal to. You see the difference? Commutative property of addition or multiplication, you're adding 2 numbers together and then you're switching the order. Or you're multiplying 2 numbers together or switching the order. That's not what's happening here. You have equal sign and you're switching. You see what I mean? So this is very different. So please be careful. A lot of times people get this confused with commutative property. The name of this is, imagine that I could draw, if I were to draw like a line through. You see how the left side is exactly like the right side, sort of like a mirror image? So like number 8. Number 8 is symmetrical, isn't it? Left side is like number 7 isn't symmetrical. What other numbers are symmetrical? 0, sure, 0. 8, we talked about 8. Are there any other? 11, I guess, yeah, okay. 11, 22, yeah, I guess you could. Yeah, so this, guess what? Anybody want to guess what this is called? It's called some kind of property of equality. Anybody want to guess? This is sort of symmetrical, isn't it? Yeah. Symmetric. It's symmetric. It's just symmetric property of equality. Okay, so that's what that's called. Okay. So imagine that you draw a line right here. You see how on the left side and right side they're symmetrical. So you can think about it that way. Okay. So A equals to B, then B is equal to A. Okay. So please do not get this confused with commutative. Commutative is you will need some sort of operation, right? Addition or multiplication. Here it's just equal sign. You're switching. Okay. All right. Let's move on to the next one. Then here, this is one that a lot of you are telling me already. If I have A is equal to B, and then you got B equals to C. Anybody? Can somebody draw a conclusion? If this is true, something has to be also true. Raise your hand if you. Oh, how about? I would like to ask Brandon. Then A has equals to C, right, Brandon? Why do you say that? You're right. Yeah, A and C are both equal to B, therefore A and C must be the same value. Does that make sense? Exactly right. So that's the conclusion. Now there's this property again is some kind of property of equality. Anybody know what this is? Dana? This is a transitive. You're right. Transitive. This is. Okay. I even gave you an example. I could, if 7 plus 7 equals to 2 plus 5 and 2 plus 5 equals to 1 plus 6. What do you know about 7? 7 is equal to, of course, 1 plus 6. Now the way that I like to remember this, you see how it's kind of long, and you see how there's a B right here and another B right here. Those are sort of the same. It's like a train, isn't it? Train. The trains are kind of connected by sort of this B. You could think of it as an anchor, or the same thing. So it's sort of like a train. So I like to think of it as transitive. If you forget. So this is called the transitive property of equality. So there are these 3 properties of equalities that you should be aware of: reflexive property of equality, symmetric property of equality, and transitive property of equality. And you need to be able to identify them when I give you an example. Yeah, question?
Is it transitive because it's like
Changing?
Transit because like transfer?
Yeah, it's kind of transferring these information. You can think about it that way too. Yeah, sure. Any other question? Maybe that's a better way of thinking about it. Okay, let's move on then to the next stuff. So now here's the last property that I want to talk about. This property is really sort of easy. It's sort of obvious. Let me ask you this, guys. For all real numbers AB, meaning A and B are from any numbers from a number line, right? So let's just pick any 2 numbers. How about 2 and 3? What do you get when you add 2 and 3, class? 5. Could you get 6? No. If you get 6, guess what? It's wrong. Okay, it's not correct. 2 plus 3 is always 5. It cannot be something else, right? It cannot be something like 2 plus 3 is like 10. You know what I mean? So that's what this property is saying. It just says this. Let's see if you add 2 of those real numbers, that answer is always going to be one single answer. And it's going to be a unique real number, meaning it's going to be exactly one answer, and it's going to be a real number also, right? 2 plus 3 isn't a pizza or a car. You know what I mean? It's going to be a number, right? When you add 2 plus 3, right? It's going to be a number. It's going to be a real number, and it's going to be unique, meaning it's going to have exactly one answer, right? Can we do this for something else? Multiplication also works, okay? So if you multiply 2 real numbers, it's going to be, again, a unique real number. Does this work for subtraction?
Yeah.
Yeah, but we don't have one for subtraction, this property. I don't know. We'll talk about why in a minute. Okay. Because subtracting 2 numbers is the same as adding the
Negative.
opposite. You mean, right? 2 minus 3 is the same as 2 plus Negative 3, right? So since they're all real numbers, you don't have to restate that. What about the division? How come they don't have one for division? Anybody see why we don't have one for division? One person see it? 2? This is a nice thing to think about. Livy, what do you think?
Because division is multiplied by the reciprocal.
Right, so no, actually, even though that's true, it actually doesn't work for division. Tower, what do you think?
It's multiplying by a fraction.
Yeah, so don't you get a real number? Like 6 divided by 3, don't you get a unique real number?
Yeah.
Right, 6 divided by 3, you get always 2, and that's a real number. Why don't they include that one in here? Because yes, can you see? Yes, sir.
If you change it, it won't work.
Say it again.
If you change the order, it won't work.
What do you mean by that? Oh, well, yeah, it still works. 3 divided by 6 is 1 over 2. 1 over 2 is a unique real number. If you divide 3 divided by 6, it's always half. Right? You know what I mean? So why don't they have one for division? I want you to all think about this as a group. Go ahead, I'll give you time. Because there's a case where it won't work. You don't know? Okay, think about this. There's a case. Think about a case where this will not work. You will not get a unique real numbers when you do this. Oh, some of you already have it? What do you think, Eugene? Say it again. When you're dividing by? 0 is correct. Eugene is correct. Look, guys, if I do 3 divided by 0, what do you get? Do you get a unique real number? No, that number is undefined. It's not on a number line. Does that make sense? Therefore, we can't use division. Does that make sense? So there's a name for this one. It starts with C. Anybody know what this is called? Let me see if this will help you. I drew this picture. It's a bag. It's not a smiley face. It's a bag. Inside a bag, you have a real number line here. Okay? So in other words, I couldn't write down all real numbers. So what I'm trying to say is in this bag, you have real numbers. Is that okay? Now, when you have real numbers, when you pick any of these two numbers and add them together, will you be able to find that answer inside of this bag? Yeah, and it's going to be unique, right? Meaning it's going to be always same answer, right? 2 plus 3 is always 5. Also, if you multiply two numbers together within this bag, right? Pick any two numbers from this bag and multiply it together. Would you be able to find that answer inside the bag?
Yeah.
Yeah, and is it always going to be same answer? Like 3 times 2 is always 6. It's always going to be same answer, right? And so this bag is closed. I don't have to open this bag to add more answers into it. Does that make sense? So the name of this property is called? Anybody want to guess? Okay, one person? Tawa, what do you think?
Closure property.
Oh, have you already done this already? Okay, it's called closure property. Kind of sounds like close, right? It's called closure property. So you're exactly right. So closure property of course, if you're adding two numbers and you get a unique real number, it's called closure property of addition. If you're multiplying two unique real numbers together, it's called the closure property of multiplication. Okay? Does that make sense? So you think about it this way. The bag is closed, right? You don't need to add any more new answers to it. You could always find the unique answer within this bag. So it's called closure property. Does this make sense? And do you understand why we don't have closure property for division?
Yeah.
We only have closure property of addition. I guess you could have done closure property of subtraction, but the same thing as addition, right? It's adding the opposite. You have closure property of addition and multiplication, but we do not have closure property of division. Just like Eugene said, if you divide something by 0, that number is not defined. It's not on a number line. Does that make sense? So we don't have that. Any question? Are we good? All right, good.